Hey everyone, in this video, let's talk about what exponential functions are. We'll talk about what they look like on a graph, and what they can be used for in real life. So, an exponential function typically looks something like this. Some base b to the power of a variable, which let's just call z. Remember, it's just a variable, so that means we can use anything we want to represent it. So, remember back to when we talked about linear functions. As our input grew, so did our output. But our function always was growing at the same rate, meaning that our slope, the rate of change of our function, was always going to be the same, no matter what inputs we used. Well, now, in exponential functions, our slope will be growing or decreasing at different rates. It'll not always be constant like it was with linear functions. So, to better understand this, let's graph this function, 2 to the power of x. As we always do when graphing functions, let's first make a table of input to their matched outputs. Let's just use 0 to 5 as our inputs, as this should give us enough data to see a trend in our graph. So, 2 to the power of 0 is 1, as anything to the power of 0 is just 1. Then, 2 to the power of 1 is just 2. 2 to the power of 2 is 4, as it is just 2 times 2. Then 2 to the power of 3 is 2 times 2 times 2, which is 8. Then, continuing this trend, we have these output values here. Now, we are ready to create our graph using this data. So, let's just go ahead and create that graph now. Plotting 2 to the power of x, we can see that every step in the right direction, in increasing an input, will make our function grow in the y direction faster and faster. And this is what exponential functions do. They cause our function to either grow exponentially, which means to grow more and more quickly, or they can cause our function to decay, which means it decreases really quickly and then the change becomes smaller and smaller. To see this, let's graph 2 to the power of negative z, the same way we did earlier. So we want the outputs for inputs of 0 to 5. So let's just create another input to output table and enter the inputs 0 to 5 again. Well, again, 2 to the power of 0 is just 1. But what do we do here? We have 2 to the power of minus 1. Well, anytime we have a negative value alone by itself in the exponent, we can actually bring it to our denominator. In the next video, we'll talk more about the laws of exponents. And if you're wondering about how we deal with more complicated exponential functions, then that video should make things more clear to you. But for now, just know that we can do this. And it should help make it clear why increasing our denominator will give us a smaller and smaller number as our output to this function. So, completing the chart here and graphing the function, we can see that our outputs are getting closer and closer to 0. But every input step in the right direction, the change is getting smaller and smaller. This is a decaying function. We should also talk about the difference made if our base number, our b variable, makes in our exponential functions. If b is between 0 and 1 in our exponential function, then the function will decrease and become closer to y value of 0 as our input value increases. This is because we are multiplying a number that is less than 1 by itself, which will always give us a smaller and smaller number the more we do it. Secondly, if our base value is 1, then it doesn't matter what we raise this to the power of, as it will always be a return value of 1. Lastly, if our base number is greater than 1, we will see the exponential increase in our output as the input grows. So, the last thing I want to talk about in this video is why we learn about exponential functions. Well, exponential functions appear naturally, very commonly throughout life, and you will see this when you take more math, finance, biology, or just about any other subject. For example, if we are studying the growth of bacteria, they almost all experience exponential growth when they have enough nutrients and room to grow. And another example is money, which will always grow exponentially when compound interest is applied. This is why people suggest you start saving money for retirement as early as possible, as a dollar put in now, at year 2021, will have a lot more time to grow and exponentially grow than a dollar put in at year 2040, for example. Thank you for checking out this video, and I hope it helped your understanding of what exponential functions are and what they look like. If you enjoyed, please like, subscribe, and consider checking out our Patreon page to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.